We're continuing on with the oblique plane principles. So in other words, the basic skills you need to know and the basic information you need to know when you're dealing with anything to do with oblique planes. So to recap, we had our vertical plane, our horizontal plane. An oblique plane is a flat surface that is angled at both the vertical and the horizontal plane. So in other words, it's inclined to both the vertical and horizontal plane. That means it's an oblique plane. The traces of an oblique plane is where that oblique plane, which is in red, hits the vertical plane, is called our vertical trace, VT, vertical trace. Where it hits the horizontal plane, the ground, is called the horizontal trace, HT. Here is our horizontal trace. And we've got a very important point here where that point is on both the vertical trace and the horizontal trace, because where the corner of the piece of plastic, the piece of red perspex, hits both the vertical and the horizontal trace. So the 3 points we'd call this V, T and H. So that would be vertical trace, horizontal trace. We can also have what's called a lamina. So here we have a piece of perspex that's floating in midair. We're going to forget about the red piece of perspex for the time being. So we've got a piece of perspex that's floating in midair. The traces of that piece of perspex are the same traces, because if you look at it, that piece of perspex is part of the bigger oblique plane. So we can have a full oblique plane there in red, or we can have a bit of an oblique plane, which is what we call a lamina. So basically an angled flat surface is what we're talking about. So that triangular section is what we call a lamina. And if we want to find the traces of that plane, we basically deal with the oblique plane. I'll show you how it's done now. Right, we'll dive straight into one of the worksheets. This is oblique plane worksheet number 7. It's on page 107 of the booklet. So we've got a question here. We've got a lamina resting on an oblique plane. So this is basically a triangular surface, and it's angled at both the vertical and horizontal plane. So basically a triangular surface lying in space. We have to locate the traces of the plane. So you can see the plane at the minute doesn't hit the vertical plane. Here's our vertical plane and plan, and it doesn't hit the horizontal plane. So it's basically resting in midair. In midair, we can't find the traces. To go about finding the traces, what we do is we're going to take our plane and we're going to pretty much extend it. If we make this bigger, if I extend it down, it's going to hit the ground at the horizontal trace. If I extend it back the way here, it's going to hit the vertical plane at the vertical trace. So we're going to make the lamina bigger. To do that, I'm just going to extend on the lines. So in elevation, I'm going to extend the lines on until they hit the ground. So here, I'm going to extend on line 1, 3. And we're going to call it 1, 3, and I'm going to call this point S, for example. I'm going to extend on line 1, 2, and I'm going to call that T. Just giving them any random names. Now what I can do is I've got a straight line 1, 3, S. I can come along and do the same in plan. So I'm extending that out, 1, 3, S. I've extended out line 1, 3. I just find point S in plan. So there's S in plan. Same thing, I've got a straight line 1, 2, T. I come along and I extend line 1, 2. And when I take T down to plan, there is T. So I've got an S and T. Now you'll notice when I extend it out, S is on the ground. T is on the ground. And if those 2 points are on the ground, it means they make up the horizontal trace. So when I draw it in there, when I join those two together, that is the horizontal trace. So I've extended those 2 lines on to hit the ground. So what I've done in the SolidWorks model is I've joined the line down, and you can see the line extends on, hits the ground, so it's a point on the horizontal trace. Same on the far side, extend that line down and it hits a point on the vertical trace. On the horizontal trace as well. I can do the same then to find the vertical trace. If I come in the opposite direction, I take that line and extend it out. So both lines were extended out in the opposite direction, and you can see it comes out, hits the vertical plane, and which is a point on the vertical trace, and the same thing, I've extended the line up, it hits the vertical trace again. And that gives me 2 points on the vertical trace, 2 points on the horizontal trace, and again, point T there is always on both of them. So that is how we create our traces. We extend the lines on. Okay, so I found the horizontal trace, I'll find the vertical trace now. We're going to do it in the plan. So I'm extending on now line 1, 2. Again, I just take line 1, 2 on to hit my vertical plane. And I'll call that W. I'm just giving it random names. I come along and I can extend out 1, 2, and it will go off the page, so I can't use that one. So I'll come along here and I'll extend down 1, 3, for example. Sorry, that's line 2, 3. 2, 3 to hit my vertical plane. And I'll call that Z. Again, 2, 3, I extend it out in my elevation, and when I take up point Z, I get Z in the elevation, and there's point Z. So I get 2, 3, Z, which is what I did in plan, extended it out. Again, here's point Z, and we said that the point T is on both the vertical and the horizontal trace. So all I need to do is join those together. So I could have taken 2 lines, but I don't actually need to. That is how we get our vertical trace. So vertical trace and our horizontal trace. So VTH as it's called. Moved on to the second, question 1 on the page is the other question. I have to locate the vertical trace. So to locate the vertical trace, again, I work from plan. What I'm doing is extending 2, 3. It doesn't matter, I could extend 1, 3 either, or 2, 3. 2, 3 is just going to work out a bit better. I extend 2, 3. And what I'm doing is extending it to hit the vertical plane. So the vertical plane is in plan. So I'm getting 2, 3, I call that point P, for example. When I come along, I extend the same line, 2, 3. Here's 2, 3 in my elevation. And again, take P up because P is on that line, 2, 3. Here's P. That gives me a point on the vertical plane, the vertical trace, and I can join it back down here. So again, because I had this point T, which is common to both the vertical trace and the horizontal trace, I don't need a second point. I could have gone with a second point. I could have taken, for example, 1, 3 out and found it in elevation, or I could have taken 1, 2 over here. It just would have gone off the drawing. I found the vertical trace. Now, it's very, very handy having those vertical trace and horizontal trace. For example, if I have a point, I'll just pick a random point over here. And I'll call it point D. If I want to find that point in plan, I have a very important principle I can use. If I take that point straight down to plan, I know the point is somewhere here, but I don't know exactly where. For me to find that point in plan, what I can do is draw a horizontal line. My horizontal line that I draw, I'm going to draw it, I'll draw it with a broken line here, and I'll call it DZ. It doesn't matter about the names. So I've got a horizontal line DZ. I can draw that line in plan now. I'll take the line Z down to plan. Z is on the vertical trace. Vertical plane in plan is here. So this is where point Z is. Z is touching the XY line in plan. So that's point Z. I've drawn a horizontal line, and I've drawn it on purpose because I've got a horizontal line in plan. Here is my horizontal trace. So this is the horizontal trace. It's a horizontal line. So the horizontal trace is obviously horizontal. The line DZ that I drew is horizontal. If two lines are horizontal, they're going to be parallel to each other. So in other words, those two lines, when I draw them, are both parallel to each other. So I can come along and I can draw parallel to the horizontal trace. So when I come down here, take my two set squares, come parallel to the horizontal trace. So here is where my broken line is going to be in plan. I know point D is going to be here. So here is where point D has to be. and that is how we find the elevation in plan. That's really important when we want to take points from elevation to plan. I could have done the same thing from plan. If I had the point D in plan just, I would have come parallel to HT because I know this is a horizontal line. Take the line parallel, bring point Z up to hit the trace, and then I can come and draw a horizontal in elevation. Because I knew from drawing a parallel here, there would be a horizontal line. So that is our horizontal traces.